Hello everyone. Welcome to another lecture on reasoning ability and problem solving. In today's lecture, we will discuss the practice questions for logical reasoning. So before we start discussing the questions, let us look at some concepts. Let us revise some concepts. So the first concept was what are odd and even numbers. So we know that odd numbers are numbers whose unit digit or the last digit basically it ends with 1, 3, 5, 7 or 9. Similarly, even numbers are numbers whose unit digit is 2, 3, 4, 6 and 8. So this is how you identify odd and even numbers. Then we know the concept of prime numbers. Prime numbers are numbers which have only two factors, 1 and the number itself. So only two factors are there, which is 1 and the number itself. Correct? Now, based on this, between 1 to 100, I have told you to remember the number of prime numbers. So in total, there are 25 prime numbers between 1 to 100. What are they? 2, 3, 5, 7, 11, 13, then 19 or 13, then 17, then 19, then 23, then 29. Then we have 31, 37, 41, 43, 47. Then we have 53, 59, 61, 67 and 671. And then we have 73, 79 and 83, 89 and 97. So these are your 25 prime numbers that we have. Okay, so these are your prime numbers. Then I told you to remember the squares and the cubes of certain number. So I am clearing the slide, but take a look at the number of prime numbers. Okay. Then we have certain squares and cube numbers. So I'll write the squares first. So squares I've told you to remember from 1 to 30. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, 8 square is 64. Then 9 square is 81, 10 square is 100, 11 square is 121, 13 square is 169, 14 square is 196, 15 square is 225. Then we have 16 square which is 256, 17 square is 289. Then we have 18 square. 18 square is 324. 19 square is 361 and 20 square is 400. Clear? Remember? Now 21 square is 441. 22 square is 484. 23 square is 529. 24 square is 576. 25 square is 625. Remember? Now 26 square is 676. This is 676. 27 square is 729. 28 square is how much? 784. 29 square is 841. And we know 30 square is how much? 900. So these are your squares from 1 to 30 that I have told you to remember. Apart from that, I have also told you to remember cubes from 1 to 20. Correct? So from 1 to 20, I am writing cubes. 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is how much? 64. 5 cube is 125. 6 cube is 216. 7 cube is 343. 8 cube is 512. 9 cube is 729. 10 cube is 1000. Up till here you know. Now 11 cube is 1331. 12 cube is 1728. 13 cube is 2197. 14 cube is 2744. 15 cube is 3375. Then 16 cube is 4096. Similarly, 17 cube is 4913. 18 cube is 5832. 19 cube is 6859 and 20 cube is 8000. So these are your squares and your cubes that you should remember. These will help you solve questions like these. Okay. So squares from 1 to 13 and cubes from 1 to 20. This much you should remember. Now, let us look at this question. So I am erasing this slide. Now, let us look at this question. In each of the following questions, 4 numbers are given. So out of these, 3 are alike in a certain way, but the rest one is different. So basically 4 options are given. One of them is different using a logic. So first we have to identify that logic and then we have to choose the one which is different from the rest 3. That means we have to choose the one that is odd one out. Okay. So now let us look at the options. If I look at the options, 27 is what? 27 is a 3 cube. Similarly, 64 is a 8 square. 125 is a 5 cube. And 144 is a, if I look at this, 144 is a, basically it is 12 square. So now we have 2 perfect cubes and 2 perfect squares. So probably this is not the logic. Now if I look at this number, this is a odd number. This is a even number. This is a odd number. And this is again a even number. So the logic is again not based on odd and even numbers. So this is not the logic. Neither the cube is the logic nor is the square any logic. Now, but if look at these numbers, 64 is 8 square, but 64 is also known as 4 cube. Correct? 64 is a number which is 8 square, but it is also 4 cube. This number 125 is a perfect cube. Correct? But is it a perfect square? No. 144 is a perfect square. Correct? 27 is a perfect cube. Only 64 is a number which is a perfect square. Plus it is also a perfect cube. So 64 is a number which is both a perfect square and a perfect cube. Therefore 64 is the odd one out. Okay. So 64 will be the correct answer to this question. Now let us look at question number 2. Now before we start question number 2, let us take a question. So let us take a question that there are 4 options. Okay. My first option is 16, 6 and 64 and 49. Let's say these are my options. And I have to find the odd one out. Now over here, I can use a logic that I can call it logic 1, okay? First logic is that 49 is the only odd number. Correct? 16 is a even number, 6 is a even number, 64 is a even number, only 49 is a odd number. So my answer will be that option number 4 is the odd one out. But if I look at this, I can use logic number 2, that 6 is the only number which is not a perfect square. Which is not a perfect square. Correct? Because 16 is 4 square. Similarly, 64 is 8 square and 49 is 7 square. But 6 is not a perfect square. So according to this, my answer will be option number 2. So whenever we have questions on odd one out, in your examination, you will have only one option which is correct. So only one logic will be used. But over here, in these kind of questions, sometimes more than one logic can be applied. We can apply 2 or 3 different logics. So when I am solving a question, I am using either of the logic. When you solve that question, maybe some other logic is being used that you look at. And when let's say a third teacher is solving this question or a third student is solving this question, they can look at it in a different way. They can find a different logic and then find the answer. So these questions that we are currently solving can have more than one answers. But in your competitive exams, in your questions, you will not really see more than one correct option. And even if there is such a case when you can see more than one correct option, then you will also see a option number 5, which will be called that data is not adequate. Data is not adequate or data is not sufficient. So whenever you see an option like this that says that data is not sufficient, you will check on this if you are getting more than one correct answer in your exams. Okay, so now let us come back to this question number 2. Question number 2, 4 options are given, one is different, we have to identify which one. So very simple, 11 is a prime number, 13 again is a prime number, but 17 is also a prime number, but 15 is a composite number, it is not a prime number. So hence option number 3, 15 will be the correct answer to this question. Okay, now question number 3. So question number 3, I can see 1, 2, 3, 6, 2, 3, 4, 6, 4, 5, 6, 6 and 5, 6, 8, 6. So just by looking at the number, I can see these are arranged in increasing order of numbers. Correct? These are arranged in increasing order of number. Similarly, this is also arranged in increasing order of number. This also is arranged in increasing order of number. But this one, 5, 6, then 8 and then back to 6. So this one does not follow the same pattern. Hence, option number 4 is the correct answer to this question. Okay? Now, question number 4. We have 7, 15, 31 and 57. I can see these numbers are very close to perfect cubes. 8 is a perfect cube, correct? Similarly, I can see this is not a perfect cube, but 8 is actually 2 raised to the power 3. Similarly, if I see a number very close to it, 16. 16 is 2 raised to the power 4. If I see a number very close to it, 13, which is 2 raised to the power 5, and around 57, I can see 64, which is 2 raised to the power 6. Okay, so 2 raised to the power 6 means what? 2 into 2 into 2, 6 times. Like this. So this will be 2 into 2, 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, and 32 2s are 64. So over here, I can see they are very close to 2's power, not perfect cubes, 2's power. So 2's power, if I see, this is basically 2 cube minus 1, correct? And this is basically 2 raised to the power 5, 2 raised to the power 4 minus 1. This is 2 raised to the power 5 minus 1. But this one is 2 raised to the power 6 minus 7. Upon minus 7, we will get 57. Correct? So over here, this was the logic. That is, we were having a 2 raised to the power x minus 1. This was the logic. But over here, we had to do minus 7. Hence, option number 4 is the odd one out. Clear? Question number 5. So, 4 options, they are alike in certain way and we have to find out the different one. So, over here, I can see 144 is 12 square. Similarly, 196 is how much square? 14 square. And 256 is 16 square. Correct? Only 168 number which is not a perfect square. Hence, option number 2 will be the odd one out. Okay? Now, question number 6. We have 2, 16, 56 and 128. 2 is basically 2 raised to the power 1. 16 is basically 2 raised to the power 4. So 2 into 2 into 2 into 2. So 2 into 2 is 4. 4 2s are 8, 8 2s are 16. If I look at 128, this is 2 raised to the power 7. So 1, 2, 3, 4, 5, 6 and 7. So here I can see 2 into 2, 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64 and 64 into 2 will give me 128. So this is 2 raised to the power 7. But 56, if I look at 2 raised to the power 5, okay, 2 raised to the power 5 will be how much? 1, 2, 3, 4, 5 up till here. 2 into 2, 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So this is 32. And 2 raised to the power 6 will be how much? 64. So this lies somewhere in between. So this is not an exact power of 2. Every number else, 2, 16 and 128 is a power of 2. This is in the form 2 raised to the power x. But only option 3 is such a number which is not in the form of 2 raised to the power x. Therefore, option 3 is the odd one out. Clear? Now, question number 7. So, question number 7 again, we are given 28, 45, 72 and 81. So, when I look at these numbers, 81 is basically 9 into 9. Correct? 72 is 9 into 8. 45 is 9 into 5. Only this is a number, 28 is a number which is not a multiple of 9. "45, 72, 81. These are multiple of 9, but 28 is not a multiple of 9. Therefore, option number 1 will be the odd one out. Clear? Now, question number 8. Question number 8 again, certain numbers are given to us and we have to find the odd one out. So let us take option number 1. So I am adding these 6 plus 8 plus 9 plus 5. So 6 plus 5 is 11, 11 plus 9 is 20 and 20 plus 8 will be 28. Option number 2. 6 plus 9 plus 5 plus 8. So 6 plus 5, 11, 11 plus 9, 20 and 20 plus 8, 28. Option number 3. 7 plus 9 plus 4 plus 8. So if I look at this, 9 plus 4 will be 13, 13 plus 7, 20, 20 plus 8 will be 28. And let us look at option number 4, which is 9 plus 7 plus 8 plus 3. So if I do this, 7 plus 3 will be 10 and 9 plus 8 will be 17. So 10 plus 17 will be 27. So in option number 1, 2, 3, the sum of the digits were 28. But in option number 4, it is different, 27. Therefore, option number 4 is the odd one out. Okay. Question number 9. So question number 9, 246, 356, 527 and 639. So when I look at this question, I can see that 2 plus 4 will give me 6. Okay. And 3 plus 5 will give me 8. 5 plus 2 will give me 7. and 6 plus 3 will give me 9. So if I look at this number, this digit should be 8. If it was 3, 5, 8, it would be the correct answer. But this is different. So if I consider this to be 3 different alphabets, basically the logic is that A plus B is giving me C. This is the logic that is used in option number 1, option number 3 and option number 4. But this logic is not used in option number 2. Hence, option number 2 would be the odd one out for us. Okay, so option number 2 would be the correct answer. Clear? Now, let us move forward. Question number 10. So question number 10, again, big numbers. Big numbers, I assume that we are doing sum or difference. So if I look at option number 1, we have 2 plus 5 plus 6 plus 3 plus 1. So if I add these, 5 plus 6, 11. 11 plus 2, how much? 13. 13 plus 3, 16. 16 plus 1, 17. Okay. If I look at option number 2, 3 plus 3 plus 4 plus 4 plus 2. So 3 plus 3, 6. 6 plus 4, 10. 10 plus 4, 14. 14 plus 2, 16. This is different. Then look at option number 3. So 3 plus 4 plus 4 plus 2 plus 4. So 3 plus 4, 7. 7 plus 4, 11. 11 plus 2, 13. And 11 plus 2, 13 and 13 plus 4, 17. Then we have option number 4, which is 5 plus 2 plus 1 plus 6 plus 3. So 5 plus 6 is 11. 11 plus 2, 13. 13 plus 1, 14. And 14 plus 3, 17. So option number 1, 3 and 4. The sum of the digits is 17. But for option number 2, the sum of the digits is 16. Therefore, the correct answer for odd one out will be option number 2, because this is different. This is the odd one out option. Clear? Now, question number 11. Again, these are given to us. Now, if I look at this question, I can see 9 minus 6 gives me 3. Similarly, the difference between the last two digits over here, 6 minus 2 will be equal to 4. The difference between these two digits, 6 minus 1 will be 5. And the difference between these two digits, 6 minus 2 will be equal to 4. Correct? So this is not the logic. Because over here, this logic was being followed in option number 1, it was correct. Option number 2, it was correct. But it is not correct for option 3 and option 4. So it is some other logic. Now, if I look over here, 3 plus 6 is giving me 9. Okay. And 4 plus 6 should give me 10. 7 plus 6 should give me how much? 13. And 8 plus 6 should give me how much? 14. So this is also not the correct logic. This logic follows only for option number 1. But this logic does not follow for 2, 3, 4. So based on this logic, option 1 is different. Okay. Based on this, option 1 is different. But another logic let us use. If I look at 4 and 6 over here, the difference between 6 and 4 is giving me 2. The difference between 7 and 6 is giving me 1. And the difference between 8 and 6 is giving me 2. But if I look over here, the difference between 6 and 3 should give me 3. But we have only 9 here. So this was logic 1. And this was logic 2. So I told you that we can have multiple logics. And based on multiple logics, we can have different answers. But in this case, based on both logic 1 and logic 2, my answers remains the same, which is option number 1. So the first logic was 3 plus 6 equals to 9. This is given in option number 1. But for over here, it did not follow. It did not follow for this also, and it did not follow for this also. Second logic was the difference between the first two digits. So 8 minus 6 was 2. This followed for option number 4. Then this logic followed for option number 3. This logic followed for option number 2. But this logic did not follow for option number 1. So even with both the logics, my answer remains the same, which is option number 1. So in your examinations, you will get questions like these. Wherever if you use different logics also, your answer will be the same. If you remember the option that I gave you, 16, 6, 64 and 49. We did this. We got two different answers, 6 and 49. But in your examination, if you're getting something like this where two different options are there, that means your data is insufficient. You will tick that option. But even if there are different logics used, you will get a question like this, which will give you the same answer using both the logics as well. Okay, so this is your more exam appropriate question. Okay. Now let us look at question number 12. So question number 12, 361 is simply 19 square. Correct? 484 is 22 square. 529 we know is 23 square. 566 is not perfect square. 566 is not a perfect square. Therefore, our answer will be option number 3. Okay. Question number 13. 21, 69, 81 and 83. So if I look at these, I know that 83 is a prime number. If you remember the list of prime numbers, you can clearly see that 83 is a prime number. 21 is a composite number. It is a multiple of 21. 69 is a, 69 is a composite number. 81 is also a composite number. Only 83 is a number that is a prime number. Therefore, option number 4 will be the correct answer. Okay. This is 7 into 3. 69, 13. Or I can write 12 or 13 into 3. Correct? 23 into 3. 81 is 9 into 9. Something like this. So these all have multiple factors, but when it comes to 83, it has only two factors, that is 1 and 83 itself. So this is a prime number, hence this is the odd one out. Question number 14. Again, long option, so let us sum. If I sum them, 5 plus 7 plus 8 plus 8. 8 plus 8 is 16. 16 plus 12 I have to do. 16 plus 12 is 28. Option number 2. 5 plus 8 plus 7 plus 8. Again, I can see same digits, so 28 would be the sum. Option number 3. 6 plus 4 plus 8 plus 2. Here the sum is 20. 6 plus 4 is 10. 8 plus 2 is 10. So 10 plus 10 is 20. And option number 4 is 9 plus 7 plus 4 plus 8. So 9 plus 7 is 16 and 4 plus 8 is 12. So again the sum is 28. So for option number 1, 2 and 4, the sum is 28, but only for option number 3 it is 20. Therefore, option number 3 will be the correct answer. Clear? Now, question number 15. We have 392, 326, 404 and 248. Just by looking at the question, I can see that 3 into 2 gives me 6. 4 into 1 gives me 4 and 2 into 4 gives me 8. But over here, 3 into 9 will give me 27 and not 2. So in each of these options, we are basically multiplying the first two digits to get the third digit. Correct? But this logic is not being followed in option number 1. Therefore, option number 1 will be the correct answer to this question. Okay? So this concludes today's lecture. Thank you.